All right, we are live. Welcome to another episode of Bitcoin class with Satoshi. And I'm here with Dr. Craig Wright. He's a creator of Bitcoin. And my name is Xiaohui Liu. I'm his student. I'm a founder and creator of Script. So what are we going to learn today, Doctor?
Okay, so we're going to talk about a couple little bits and pieces in general. I started you looking at semantic web, and we're also going to discuss graph problems and how we can build sort of provable modules and whatever else into script. Now, an example would be we could look at doing simple solve the maze type things, which someone could prove by putting everything in there. But we could also tie that to other puzzles. So there can be different ways of getting through a problem, and that derives an answer based on which particular path you use. Now, if you think about standard algorithms for this, whether we're doing BFS, DFS, Distraka, or any of these sort of things, we can create, now that you've got matrices there, we can start creating like an adjacency graph, and we can actually start working through that. So the same way that, but everyone thinks we have to do all the calculations in script.
Maybe not.
Maybe not. So exactly. But what we can have is, here's your adjacency graph. Here's another group of calculations. And they solve different ways through like different paths, etc. Now, but also if you don't get the path correct, you put something wrong, then of course it just doesn't work, because as a predicate logic system, hit zero, hit infinite weight, whatever else, we get the wrong answer.
So how do we, I think there's always a theme, like how because in general programs, when you have some computational problem like a maze you want to solve, or a Sudoku, right? You can just code everything, the logic. But here, the Bitcoin script is always like, as you always mention, it's a predicate system. So in general, is that like the scheme is always somehow to convert the original problem into some kind of like a decision problem where you can.
So what we want to do is to, have it as a decision problem. And now we want to start thinking about how we move our logic, not only in script, but linked outside of script.
What do you mean outside this?
That's where you have, where I've talked about overlays and second layer networks and whatever else. Now, if I see something 0, 1 in script, that can mean much more in a predicate. That's true, false, etc. So remember, we have simultaneous, we can do multiple calculations and then match them up against information that we put into the alt stack or whatever else for later. So imagine that you can step through your problem and save the results and see if they match.
Okay, here we are talking about a one transaction, or it can be also multiple.
It can end up being multiples. Now, but what we're doing here is just the single part.
Okay.
So what we want to do is match up, if we go the correct path in our adjacency matrices, and we pick a correct path, we get a different result.
Okay.
So we don't need to do all the calculations. We don't need to find the shortest path or anything like this.
Okay, how is this translate to, let's say you say you don't have to do everything. How, like concretely, how does this translate to what's happening in script or what's happening outside?
Okay, so you code a set of information and path and data and whatever else in script. And then how that is interpreted outside in another application will determine what information is used and fed. potentially what is handed over from another application, a system, separate system, what may be decoded, etc. So if the two of us wanted to play a fair game,
Okay.
one of the things we could do is you could be running the service and providing all of the different methodologies, etc. And there'd be no way in the system to cheat or to change any of the rules or anything like this. You could have test structures or paths or a set contract with multiple layers of what you need to do. And once it's offered, as long as you go through those, depending on what result you get, determines where you get to. And then you could have different outcomes tied to the script as well. So input, for instance, and a path, maybe you find a shortest path algorithm on your computer outside that has a distance of 11.
Okay.
That gets you a certain result. And you can feed that into the adjacency matrix and provide that result. So extending on, for instance, even the solving puzzles, quickest way to get to it, or whatever else, we can actually have different outcomes based on different solutions.
Outcomes here, I think intuitively, I think you mean like whether the script evaluated true to false, or what is outcome?
Remember, the script can evaluate different ways. Through conditionals, I don't need to pay the same address or the same sort of condition, depending on what my conditions are, my outcomes are. So
Okay,
I can make the equivalent of what most people hate as a case statement, for instance.
Okay. All right. Okay, that's what I mean. Okay.
But it can be far more complex than a case statement.
Like
because it can have variable paths and all sorts of funny things.
Yeah, it seems to me it's just like a conditional branch, right? You have if else, but you may have nested, and then within if else you may have something. Yeah, it's another nested structure too. What would be like always? Oh, go ahead.
When I was a kid, an example of some things that used to happen when we were making games and things like the Zork type ones or MUDs or anything like this, would be setting up a grid and a framework, and you would have all of your information mapped out. Now, we could do that. We could actually make a simple MUD and multi-user dungeon, and as each player sends a move or a transaction, it gets updated, but only the sort of the full map is there. So everyone could, for instance, have an update, and that is provably this is the map, and next time it's the map.
Okay, this reminds me of what we have building this primitive called like a state to embed state. Just state here is the MUD, right? And then each transaction update the MUD according to the rules, which is encoded in the script itself. Because otherwise you cannot you can arbitrarily change it, right? If it's just in some database in some third-party server, you can probably you don't even know what's going on. I mean, is that what we're trying to do here? Yeah.
So, I mean, I'm just going to give an example of a game, but this can go into many more sort of methodologies as well. But let's continue with the game. We could put in a particular map.
Okay.
That map could be set by an adjacency matrix, where if you can go up, down, left, right, whatever else, but only certain ways. And the predicate could basically have, I'll allow this type of transaction if it was a 1, this type if it was a 0.
Okay, so it's almost like translate into this game. Maybe you're walking like in a maze, and some of the paths is a block, so you can maybe when you say left turn, but it's a hidden wall, so translate to script that evaluates to false, and the transaction will just fail.
Yeah.
Okay.
So nothing happens. Now let's take that a little bit further. Let's model that our multiplayer characters are now committing to something.
Okay.
Now we covered commitments.
Mm-hmm.
So if we build a commitment, we could have each player give a validated proof of what they're doing. That
Okay.
is, I've committed to doing this. Here's my hash, whatever else. And now, if that player wants to change their mind, that's too bad. They're now committed to doing it. But no one else can cheat and put the player's action in, because only the player can do it.
Mm-hmm. So what kind of let's say action they can commit? That's what would be one example?
Well, in a game sense, you could have the old-fashioned Zork type thing. Just have a letter for pickup, a letter for attack, a letter for whatever else. Then, of course, each player can sort of, based on that, then the game updates. The same way as it used to in old-fashioned games. You have very limited information that you need to store, because it's only binary bits representing other things, basically mapping to other processes. So if you had a graphical interface or something like that, it would be local, and all of the other data would come down from just the transaction exchange. Now, after you've done your action, you build in something like a random generator. I've made a commitment, you've made a commitment, and then
XOR, maybe
we
something.
XOR it, expose the commitments, and XOR the two numbers together, and whoever gets the highest one wins, or if it's more than this number, etc.
Okay. Yeah, this reminds me of some example we did before, like a fair coin flip, or let's say even secure lotteries on chain. Is that
Yes.
what are the
so
major benefits of doing it, let's say on chain within script versus just go to some games website and play there?
What happens if someone cheats?
Okay, so
I mean, think about it right now. Yeah, transparency. You have all the existing problems that are starting to pop up in games again, with people trying to sell hacked goods.
Okay.
So
yeah,
look at Pokemon.
Okay. Yeah, I think that's.
People make whole careers out of selling goods in Pokemon and counterfeiting them, and some people have gone to prison for it in a couple of Asian countries. But
Wow.
You can actually stop all that.
Okay.
And that's only games.
So games, I would imagine, is just one example, right? This. So go back to it's almost like a state. It can be any arbitrator kind of state. It can be like a chess or.
It can be an ongoing bidding process as well.
Okay.
So different people can bid for different parts of a contract. And all that can be integrated. If they finish the contract and it gets signed off, then they get paid. If they sort of isn't, it could be ranked, and all that information then becomes public.
I see. Yeah, it's kind of in a general field of the so-called multi-party computation, or that's one part. Like I see some examples of saying implement on-chain, say auction or voting. Auction, you can have a Dutch style or English style, the highest, whatever.
Yeah.
Okay.
Now, I also had you looking at semantic web.
Yes.
Tell me what you've learned.
I think not much. I think just pull up some introductory videos by Tim Berners-Lee, the guy who invented World Wide Web, and he's saying this. We now have originally he called it 1.0, which is read only, and then we have all this Facebook and Instagram, whatever is you can have more interactive web. So he called it kind of called read, and also you can write. So it's more interactive. But he says the problem now for all this application is again, we are always coming back to this theme, is it's siloed, right? For example, give some example. I want to update my profile picture, right? So for now I have to go to Facebook, I update, I go to Google, I go to LinkedIn, and he's saying ideally that should be just data. We're not only linking documents, web pages. There should be like almost like a single source of truth, which is data. So then you can link them all together. He called linked data. This is
so what did you see the problem as? XML's there, the lower layers are there, RDF's quite robust, ontologies like OWL, all the rule-based engines are there. So what would you see missing?
From my point of view, I think it's just, of course, if I'm a Facebook, right, I probably don't want this to happen, because then I kind of like lose the data monopoly I'm having on my users. That's just one aspect I think of.
That's possible. That's not even what I'm thinking about, though.
Okay.
That is the economic side of it, which is valid. But what about the technology side? What's not complete?
It's I'm just guessing at like a global ledger where everything can be stored and linked
if
together.
you look at something like a semantic web stack, and before you can get to having user interface and applications working correctly, there are three areas that are unifying logic starting to be developed, but it's like that. The others are proof and trust.
Okay.
So
can you talk about a little bit more? What is
that? So how do you verify that semantic web statements are coming from a trusted source?
Okay, you say you have to have some kind of like a identity, or?
Yeah, so we can build in identity, and we can start creating hierarchies of like digital signature sort of chains in the way that I envision with Bitcoin, which is constant reuse of the digital signature algorithms, but having them linked to an identity.
Okay, how is this different from the existing internet, which is kind of using PKI? You have a root certificate. Everything is kind of like a tree hierarchical signing.
We do, and what happens is you have this trust problem.
Okay.
So
how's it?
We have two conflicting things on the existing internet. We have trust and proof.
How are they conflicting exactly?
So trust statements need to be supported and verified. They need to come from a trusted source. They need to rely on some sort of formal logic that can be validated. But equally, if you're going to verify something, who verifies it?
I think could be end user.
But the end user sends something, but the server now has to trust the user. So you end up with third parties. You end up with Facebook and Google and data silos.
Okay, how's Bitcoin going to help in this regard?
So if we can start separating identity and allowing people to take control and charge of that, have that validated, proven using trust webs with government and other things to have an identity standard that links a root identity. Now, the problem, as I've been saying, is that trust and verification, well, you hand it off to Microsoft or you hand it off to Google, and you hope. You hope and trust that they're doing it right, that they're verifying your information, that they're not letting anyone who shouldn't be in. But how do you know?
Yeah, for now you don't, and you can't, and I think if history has been a lesson, is always, yeah, these companies always get constantly hacked.
Yes,
Nobody has not been.
Alternatively, you can verify by having a wide standard that's public. But the problem then is, how do you keep privacy?
Okay. So this what do you mean by conflicting? On the one hand, you want things to be open and transparent so you can verify. But on the other hand, you may leak in your personal information to everybody. Okay.
So this is where I've been saying things like being able to verify the location of a transaction. So say I send you a verification transaction.
Okay.
Make that a normal SPV thing. I can say, here it is, and it's been sent to be processed by miners, et cetera, and now you can basically do something like responding to that transaction.
Okay.
So that proves you've received it, doesn't it? So as an example, it doesn't even need to be linked. So if we have a multi-stage process, I can send something to your hierarchical subkey that maybe someone can work out. But that can now also give me information, because you can use your key plus, remember, additive properties of ECDSA, and you can now create a new key.
Okay.
You will know the password to it, the private key, and the other person will know the public key.
Okay.
And same vice versa. So I can create a completely new address, and someone else can give you an address, and we can exchange those. And now you can send something on chain, and they can send something on chain, and there can be a permanent record of all of this information that doesn't link in any way that the world will know other than participants.
Okay, that's it's a standard feature of Bitcoin, which many people miss. The address is a firewall from the identity.
Yep.
Okay.
So remind me, I'll during the week I'll get some of the white paper material for you.
Okay.
To do with some of the like key management, CA, and also sort of hierarchical updates, because one of the things we have is sending an alert, for instance.
It's not the alert key we are talking about.
No, I'm sending individual alerts. Now, an example of one of the things I thought for this would be, say you want to use your credit card.
Okay.
I could basically send an alert key that your phone and any other device you want to manage will pick up.
Okay.
You can send back something saying, yes, I've received this transaction and I authorized it, or no, there's a problem.
Okay. Yeah. Okay. Just play devil's advocate here. So how is this different from existing service? Like let's say you have some bank account, right? Whenever you get a credit card swipe, let's say sometime I go overseas, whenever I swipe my credit card, I think because I get this notice from my bank, and then I have to reject or accept it. How is this different from what you just mentioned?
You can choose how you save your key. You can choose how you manage it. It is a more secure way of managing your keys. The bank's not involved at all. Completely no requirement for them to maintain anything or update anything. Okay. Right now, their app, their keys, which you can sit there going, oh, well, they wouldn't lie to me or whatever else, but it doesn't always work that way.
I see. Okay. Yeah, it seems you can do the same functionality, get the instant notification, but it's just more secure, even cheaper always, for them.
There's always web type things, but this is why it's everyone has their own identity system right now.
Hmm.
So what you're mentioning is, yes, we can do this, but think of what we have to do. The bank has to have an identity for you.
Mm-hmm. Okay.
And they have to maintain that. And someone else you go to has to have an identity for you.
I see. So yeah, this is this one of the theme you are going into this semantic web, because instead of like everybody has their own, every app you go to have their own, let's say, identity. You because
Wouldn't you
for you,
prefer
you
to
just
manage it? I mean,
yeah, it could be.
there are different ways of controlling it, different ways of always in real world getting keys back and other things. Not like people run around and say you lost your keys and your identity's gone.
Okay.
No. You'd want to protect that. The variety of things that can be done for recovery. But then all of that can be put out there so that if something does happen, everyone knows immediately. It could be alerted, hey, my key's been stolen. And instantly someone goes, that message came from the Korean government. I don't trust North Korea.
You don't?
So I'll ignore it.
I trust. Okay. Kim Jong-un, I mean, he seems friendly. Anyway.
Yeah, I mean, they want to do another thing where they dig a hole underneath the DMZ, I believe.
DMZ?
I think they plan on managing the wildlife or something like that. But yeah, anyway, that's off topic. But so think about what we can start doing is allowing people to have more control over their own sort of information and access.
Okay.
So rather than handing it off to Facebook or Google and I mean, you've seen a lot of these things now, and Facebook acts to a lot of sites as a authenticator.
Yeah, the OAuth, it's just logging.
Yeah, but what does that mean? Have a think about it. What does it mean if you're using Google and Facebook and a couple of the others, and that's it?
I think the one benefit I could see, I think for a lot of users, is just they don't have to sign up and register for every new website they encounter. But the downside, of course, I think especially in the current political environment, is if they don't like something you do or the website they're doing, they can simply just deplatform you, and there's not much recourse.
And it can be worse than people think, because imagine if you're deplatformed and you're linking into university sites or books or other things.
Okay.
I mean, they can actually wipe out third-party applications by wiping out your Facebook profile. So, I mean, for instance, I have a number of university sort of library sites and things like this that give me access, and they allow me, instead of my university login, to choose Google or Facebook. What would happen if, say, Facebook decided to deplatform me and I'd been using that?
Then you lost all your access to even your libraries.
Yeah, exactly. So then I have to go to the university, all my saved books are gone, all sorts of fun things.
Okay.
So
yeah, I could see this trend. Is this how you see like one application of Bitcoin into this so-called semantic web?
Yes, I want to see people having more control of their own sort of destiny, reality, and all the rest. I mean, as someone who ended up having problems with Twitter, so to speak.
Okay.
Not that I can say that, not that that was too bad. I mean, gave me more time in the day, but anything linked to that then is also gone. So, but if you own your own, and there are ways of controlling that and proving who you are and all sorts of fun things, then, well, one site kicks you off, that's too bad. And more than that, what if you can now start creating semantic parts of identity in a schema? What if I can say and have verified that I'm proven to be licensed as an accountant, but I want to be able to say something. Maybe it can, using trader tracing, it can be uncovered by the ACA, who might come in there and go, that you can't say that sort of thing and cite me. But normal people won't ever be able to see what I'm doing.
Mm-hmm.
So normal people will then see that some accountant who wants to say pseudonymous, because as I said, it can have a backdoored function so that the organization won't let you use being an accountant and saying bad things against people randomly. But equally, you could verify that you are an accountant.
I see.
I want to say bad things about the tax office or whatever
Australian?
else.
Okay.
Probably.
Okay.
I don't actually have anything bad to say about the
That's it.
HMRC other than they take my money.
Okay.
But,
So yeah, I kind of see this scheme. I think a lot of people, I don't know, maybe you don't like this term, but people call this is it own your own data? Is this
yeah, I mean, it's a bit more than that. I mean, I don't like own your own data. I'd prefer to, we need a better term. I mean, own your own identity. And
okay?
I'm not going to think of that one. I'm not a terribly good marketing person.
Marketing.
Marketing was probably my worst subject. I got a B in marketing when I did marketing for my MBA stuff. Was my worst thing.
Let's just say that let's say what you envisioned, everything is comes to life. How is this different from what's happening right now? Let's say this semantic web, if it comes into full realization with the help of Bitcoin technology, maybe some other technology, but how is this different from the existing internet we're having now?
Well, it allows people to maintain a level of privacy for a start.
Okay.
Not anonymity. I'm going to keep saying this one and honing it down, but privacy.
Privacy. Okay.
So the way I look at it is, it has to be a level of hard work for the police who have to just not do the NSA type, look at all the metadata and troll through, but actually find someone and trace backwards, and that would be doable.
Okay. Yeah. Privacy. And
yeah, get the search warrant, trace back properly, maintain your privacy, the good old-fashioned type way. Now, from that though, there won't be any tracing. So there's no one selling your data unless you want to give it to them. And if you do want to give it to them, you can, but someone has to ask you. Someone has to either pay you for it or give you a service or do something.
Okay.
I mean, if I get, I mean, it's the old, at least take me out and pay for dinner before you decide to use me.
Okay. Yeah. And you have a choice. Okay. Yeah,
Exactly.
good. Let's see. I think just to play the devil's advocate here is, I think it's a lot of, I think, news applications or website, they have trying to use this privacy to compete with, let's say, Facebook or Google, which offers free services. And so far, no one, or nobody no one has gotten a significant user base.
No,
I mean,
but that's because
it's just
they're not really free.
Okay.
So Facebook aren't free.
Yeah.
Facebook,
That's what I'm saying. But at least for now, the users seems like they just, every time you have some scandal or room, then after it becomes like a Cambridge Analytics, right? Then after a while, people just go back to Facebook or Google again.
Well, there was a compromise just the other day.
Yeah.
Tens of millions of user accounts or more. I got notified, and I don't even use Facebook. There's a work Facebook type thing that was set up and that there's on there, and I'm sitting there going, I didn't even realize my Facebook account didn't even have one. I mean, oh, so work people post things about me and whatever else. That's nice. But because of that, they still have information and they still trace against my name, and they, what can we say?
Yeah, Yeah, that's what I'm saying. Is seems to me a lot of at least, I mean, I could imagine some people that may, you know, they may prefer privacy over like, let's say whether it's free or not. But it seems at least for now, the majority of people, like average Joe on the street, he just care about he doesn't worry too much about the
Well,
privacy. Is that
there's not really any alternative that I can see. There's no way of paying for access or getting money back. So, I mean, an example of something you could do would be paying for access, as I've noted many times, but potentially even having subsets that prove some of what you've been doing over time, so that you could use a filtered version of that to give you recommendations and other such things. Now, the difference there would be you would be in control. So potentially you could even have a service that you could go to and pay very small amounts, or even they would pay you for the fact that they could get advertisers to you. So rather than Google making money from advertising, which is what they do, imagine that some ad company, like if I want recommendations, these are the sorts of things I look at. This is what pseudonymously I'm going to give you information about me. I could have an application on my end that filters information, gives out limited anonymized data. The service then spits back information about the sorts of things I want or like. And they never know who I am.
Okay.
So they get partial information. I mean, this is sort of where we can take it as well.
Yeah, I think one technique I've been looking at for the past month or so is zero knowledge proof coming into mind, or you can do a lot of computation, but you don't know the inputs.
That's correct. So have you looked at anything like Pinocchio before?
A little bit, yeah, the ZK Snarks style.
Yeah, it actually goes before ZK Snarks, but there are a number of computational engines that allow you to do sort of shared homomorphic type information exchanges without giving away who you are or what you want to do. As I said, some of that can be built up even on what do you call it? Coin flipping type algorithms, or other simple things where I don't know A, B, which way you go. And from there, what's your next area that you want to work on and build? I got a lot that I can give you.
I think one thing I think you've been hitting, you talk about this a few times. I think especially in the, I think last CoinGeek, you talk about this outsourced computation. So basically, for computation, a lot of times people just care about the computation, right? For example, you want to run some algorithm, find some solution. You don't actually want to run some servers on the cloud. You don't care about the machines. So that I think I searched a little bit on how, I think InChain has some work on initially on how do you verify. In a general term, they call it verifiable computing. So I think that would be very interesting. The benefit I could see is one, you can, for some program, you can verify it within script, but you don't have to rerun the whole thing.
So
it's
as I've been saying, what you want to do is find things that are differentially able to be worked on and verified, so that you have a lot of work can be verified very simply, which is really what the entire thing of hashing or what do you call it, like public-private key pairs are about. A lot of work one way, a little bit of work another way. But it doesn't even, I mean, where people go wrong is they always think it needs to be as difficult as like public-private keys to a secure level. It doesn't. It can be economically viable because you can always add a trusted key and other work.
Okay.
And if it costs you a lot of money to do a verification and it's cheaper to buy it, then nobody's going to go out there and then they can do it on their own anyway. If you see what I'm saying. Why would you go out there and break all the effort to try and find out what I'm exchanging with you when for half the cost you could just do the same calculation, that sort of thing.
Okay. I think, yeah, that's one aspect I'm definitely interested because one thing I just mentioned, you can, for one thing, you can, for many applications, you don't have to rerun, so that can save you a lot of costs. And on the other part, is also privacy, right? Coming back to the semantic website, because, for example, yeah, but you probably don't like this example because it's a zero knowledge contingent payment. You know, it's a device by somebody who may not be a favorite person, but I think it's a cool example of usage for Bitcoin. I mean, not for that specific ransomware or something, but you can have legitimate use cases. You know, you convert some problem, let's say Sudoku, to like equivalent hash puzzle. So when you run on chain, one thing is you don't have to verify the whole Sudoku. You just verify the pre-image hashes to a certain value. On the other hand, for everybody else who's only look at the on-chain activity, they only see the hash puzzle. So they don't know you are solving either for traveling salesman or for Sudoku. They don't know, and it's also good for privacy too. I think it will be very good. I think of looking at some other chains, at least Ethereum, they have some toolings, but we don't have toolings yet. So that would be something I personally feel.
It would be good to get all those things in. The benefit we have is we don't need to run everything everywhere all the time. This is the Ethereum problem that they haven't figured out is a huge problem. You don't want to have everyone running everything. If I want to use Ethereum as money, I don't want to use it as CryptoKitties as well. And that's too bad. Everyone has to do it.
Is this how you see the long term? What's going to be computed on chain? Is it like most of the time, if not all the time, you just convert the original computational problem into this like a certain kind of like a zero knowledge, which is shorter and more private? Is this how you see the on-chain computation?
Yeah, definitely. And I mean, that can be used in also proving that you've done a calculation and then getting paid.
Yeah.
In which case, people will go, oh, but someone might rip you off. Well, then you have something like nLocktime or whatever else, and you have a way of grabbing the money back, or you have a third-party arbitrator or something. And if you're worried about them doing that, then put up a bond. If they do something naughty, put up a bond. So what I'd like you to also sort of have a bit of a read on, and I will get you some material on what we have already covered. So we'll start getting something there so you can code. But I want you to start having a general read up on an old technology, first of all, which is broadcast encryption.
Okay, I think, yeah, it's probably in the cryptography, the Schneider. I think I see the term, but
yeah. Okay. I don't think he covers it really well. It used to be very common back when people had set-top boxes and sort of satellite groups and whatever else. Now, what it would allow is for differential decryption based on, like, I've paid for this, you've paid for that, I'm on the full package, you're not, that sort of stuff. And a single stream would decrypt differently to different people.
I see. So it's kind of you are doing, let's say, it's almost like to me, one example I could imagine, you imagine everybody have Netflix. But Netflix, instead of streaming it to you, they just using wireless. And depending on your subscription plan, you just get the different content, even if you receive exactly the same data. Is this what it
so
enables?
you can actually pay for different keys, for instance.
I see.
And as you pay for different keys, you get different access. Now, that would allow Netscape, for instance, to effectively just have the, like if they're doing a broadcast of a football game, they could have the football game streamed simultaneously to everyone, but different people get different levels. One person may get the like one bit of access, another person will get a higher level of access with interactivity, all sorts of fun things. So the same way that we used to be able to broadcast by satellite, and the satellite would send out one big blurb to everywhere, and then the set-top box will decrypt it, depending on what key you have.
Is this something already, to me, is this something, it's already been deployed? No, because I have a satellite TV and,
Similar, but
how's Bitcoin coming into play?
Okay, so we can have information sitting there on chain or on a DFS or something like that. It can be permanently stored, and over time, we can give out different keys that can even be revoked.
Revoked.
So there are revocation algorithms that exist within some of these protocols. So we can, over time, continuously update and revoke keys, even though the source file is actually stored on chain.
Okay.
I know, sounds like magic, but it's actually doable.
Yeah. So, okay, you mean the source file is stored on chain, like you're not saying the whole, let's say, football game, or is it something else like a
no, it could be a movie, for instance.
Okay.
Could be a movie is up there. We don't want people copying it and doing other things, but they can stream and frame by frame access or something like this. And as long as they keep paying, they can do it. But it's sent out in a special format that sort of gives them whatever they paid for. So we looked at differentials in splitting the quality, for instance, with SUD and things like that. So we can do the same sort of thing here.
Okay, so instead of like a picture, you may do it even for frame by frame. Then you get a different resolution or different.
Yes.
Okay.
So we can have different people accessing different files, or even in one block, multiple files could be stored, but only partial access. So if you've only got access to that part of it, not this other part of it.
Okay. Yeah, I think one thing I've always been amazed is this, because this seems like a conflicting goal here. One is saying if you store something on chain, it's always available there. And now the way you sell it is by sending, some kind of like a decryption key. But you always also mentioned there's some way to expire that key. But how is that possible? Let's say you send me some video and now you give me the key to decrypt it. Wouldn't I just, the key is always there, right? There's no, you say there's some way to revoke it. Is that something possible?
Yes. So if we look at combination of different methodologies, including what we were just talking about in broadcast encryption and PUFs, for instance. One of the areas
PUF?
PUF and PUFs. Yeah. So you have you know what a PUF is, first of all?
Yeah, it's some physical, I forget the name. Kind of like a unproducible function. I forget. Physically.
Yeah. Unclonable.
Okay.
So we're looking at unclonable hardware devices, things like that. which are doable as well. So, for instance, people say, "Oh, how do I make someone do that?" Right? How do I make someone take stuff? Blah blah blah. But we've all got these, right? They've got cryptographic hardware in them.
I see. Okay.
Do you set the parameters?
No.
So why wouldn't we be able to get in the future unclonable sort of chips that are unique in every phone or every device?
Yeah, that's possible. But again, I would imagine some people just screaming here like, then you are trusting Intel or let's say some chip maker there.
Well, actually, I mean, you're not really, because the way that a unclonable sort of device, it's in the era, and you can't actually make a clonable. There isn't a, I mean, unless Intel have some secret that nobody knows about, there isn't a way of making these flawed chips that match.
Oh, okay.
And that's part of what it is. It's actually an error, in effect, is where all this started. So errors in processing that created slight differences in every single batch of chips.
Oh, okay. So it's not something they can control. It's almost like, you know, let's say
Every
ECDSA,
key will be different. Like I throw down a handful of marbles, and can I control where they all end up? No.
I see. Okay.
And as you know from keys, one bit moved a little tiny bit is very different.
Oh, okay. That's good to know, because I thought it was, you kind of have to trust the chip maker to make sure it's all unique. I would think about like it's like you have this Wi-Fi card, you have all have a MAC address, but that's something.
Yeah.
Actually, I would think about more like a MAC address, but it seems not.
Well, I did that one
can...
for. I bought Ethernet cards from a Chinese sort of hardware vendor one time, and I had 100 cards, all with the same hardware address.
Okay. Okay. Yeah.
And the person's going, "I'll just change it."
Yeah. Yeah. Okay. So PUF is not. That's impossible, even from the chip maker.
I mean, if you got there with a electron scanning microscope, you could do the IBM bit, move it atom by atom.
Okay, I understand that. Okay, I think that's probably too expensive to massively.
Exactly. I mean, IBM have made IBM in single atoms, so given enough time and enough effort, they could probably do it. But
not in mass production.
Think how, yeah, exactly. Think how many atoms you have to actually individually move. Probably not.
Okay.
So we could actually, I mean, that's an area of research that we've been looking at. And in the future, there could be like chips that tie the device, that it's unclonable, can't copy. And then I have now a key that I have something that I own. Now, that can equally be redeployed. Remember, we can change where Bitcoin points to. And that Bitcoin can point to A or B. Or, for instance, if you're using my movie viewing service and you're no longer able to access because you dropped your phone and it got hit by a truck, but you've paid for the service and you get your backup, then it would be possible for us to basically disable and redeploy.
Okay.
Okay.
So if everything goes right, it's fine. But in terms of emergency, you can always have a way to like a recourse.
Okay. Example would be I've just been setting up access and accounts on my phone here. And although I've had sort of an overlap for the last month, I'm finally fully moved across to the new phone because I don't like the Google authenticator and the Microsoft authenticator and all that stuff, you need to go and get new codes and all that.
Yeah, that's
BS.
that's very complicated. If you lose your phone, the authenticators, those are very hard to recover.
So it takes you a while. So you want to have the old phone sitting there and the new phone. But all of that could be made a lot easier as well.
So,
and then we could basically repoint you.
I see. Okay, so we just talked about this PUF idea. I think some other blockchain, they try to use this, what is it? It's also like a hardware security assumption. They have to assume the hardware. I think it's called SGX. They have to
but what they're trying
is that how are these two different, like PUFs and SGX?
Well, they're trying to do it for mining. They want to do decentralized because everyone has their own. That's missing the whole point of Bitcoin, and which isn't radical decentralization like everyone keeps running around and saying. It's about security, privacy, making sure that everything's verifiable, all those sort of things. But it's not about every person and their dog and their grandma gets to run their entire system and have a node. So.
Yeah, I think a related question, I think for myself has always been pondering whenever people say own your own data or whatever term you call it, but where's eventually where's the data is going to store? You don't want your grandma to store all her personal data on her phone or laptop, right? Is it?
Yeah, I mean, I don't see that you need to own your own data. I think you should be able to, by own your own data, I don't think it means you have it. You should own it. Now, just because I leave something at a parking lot doesn't mean it's not my car anymore. So in effect, there's a bailment, but I own that car, even though it's sort of stored or valeted or anything like this. So I think people have got to start getting that sort of notion that they can own it without having to control it or be in charge of it, or even possess it. They can hand over possession and maintain control and ownership.
Okay, I think one way I could imagine is, let's say Dropbox, they still have my data, but it's encrypted. Only the keys, all the keys are at my side. Is that one way?
Exactly. So Dropbox could ensure that it's all backed up. They can ensure the integrity, but not even know what the hell you have.
Okay.
I mean,
yeah, that's one way I could imagine.
Yeah, I mean, I'd be happy with that. With
what
Google
if
not reading all my damn files and
email?
everything I store? Yeah.
Yeah, I think again, related. I think we briefly talk about the zero knowledge proof kind of multi-computation, where you can keep your privacy while you can also do a lot of computation. But for my limited understanding is that for now, the technology only allows you if the computation or the data is smallish.
Yeah.
So
correct.
Because you have to encrypt with all the circuit. If it goes big, billions of circuit, you cannot reasonably do it on your personal device. Is it so for that kind of like for mass adoption?
That's why you want to split it out again. So that as I said, you want to have part of the computation done off chain and part then verified on chain. So before any mass adoption, that's really got to happen. This is again the problem with all these other things that are trying to massively decentralize, like Ethereum. They want everything distributed to everyone, but why? I don't want to run someone else's CryptoKitties.
No, unless you want to. I mean, so just again, play devil's advocate. So if this kind of technology can be used within Bitcoin, can they also, like some other chain, they can also use this kind of a technique, right? What's stopping them? Is it just patterns or?
Fairly much, yeah. Law.
Oh, okay. Yeah, we see some.
Why do you think they all hate me? Why do you think they form crypto alliances and everything like that to go, Craig's a nasty man, he won't share.
Yeah, it's I think if they come up with the patterns before you, they probably they will be happy with that.
Well,
But,
I mean, the irony is they all sit there saying how evil I am because I have patents. But Blockstream filed 3 patents.
two
and-
patents, I think it's a $76 million something. Yeah.
Yeah,
75.
well, one got rejected. So they filed 3, one got kicked
okay.
out. Binance filed patents, crappy ones that I don't think any got passed, etc. So all these people have tried, and because they're not as good, they can't manage to get them through and filed, and they can't actually get something that is considered novel and new. I'm bad. How dare I do more than them?
Yeah, I think, I don't know. It's, maybe that's the reason they criticize patenting, because if they cannot, if they don't have the patents.
Well, then isn't a bit hypocritical to say you can't patent, but we were doing it before you.
Yeah, good thing is N-chain probably have much more. So I think it's one suggestion I have for this class is maybe it's worthwhile to go through at least some of the high level, the top level, what are the most important category of the patents. Maybe not only on the public information that can be shared right now.
Once they're filed and open, yes. There are some that I wouldn't actually mind starting. One of the ones that got finally granted the other week, which was whitepaper W0001. That was patent number 1 there was on general ledgers on chain.
Okay. Yeah, that could be something very useful. I think it's patentable, and we can like all the classes before we can start building.
Well, there are
some
actually
kind of a toy example we can build upon, so other developers they can learn.
Well, there's other uses too. The same way you can make a more extended version of a general ledger, you can also make a distributed registry or register. So where we're talking about some simple toy state things, we can actually make a distributed across multiple transaction state.
Yeah, that would be something I personally would imagine very interesting. And I could imagine a lot of other developers that would be very used to know what are the things that can be new things, cool things that can be built upon.
Yep. Well, why don't we make a few of those a target for you to start looking at? I'll get those off to you, and so you can look over the next few days.
Yeah, that'd be perfect. I think ideal case will be like every class we have some homework, and then either me or some other people come up with some example like what we did last time. That'd be very good. I think 1 year later we can have at least 50 examples.
Shoot an email off to Briggy and Owen and myself, and I'll make sure all those get dug up, not just the patent, but some of the white paper.
Okay, that'd be perfect. Okay. I think that's probably a good time to stop today, pause today.
And some homework and all.
Okay, yeah, homework is part of the class. So hopefully I'm not the only one doing the homework, so we can get more people. Grassroots. Okay.
Sounds good to me.
All right. Okay. Nice to talk to you.
You soon.
See you again.
All right.
Okay.
Bye.